Hello, and welcome to day two of me trying to work through these Project Euler problems. So this is, so I worked on the first problem yesterday. It was really easy. It, took me about a minute of actual coding to solve it. I have it up on screen right now. I figured today, for now, I'm gonna temporarily disband my plan of solving one a day because, initially these problems are super simple. So I'm gonna try to solve, as many as I can in maybe like 30 minutes to an hour, just to give myself, a little more time to record these streams. And as eventually these problems are going to get more challenging, and then I can go back to my plan of maybe one a day, and I imagine at some point these will get super challenging. It'll probably be like maybe like one a week. So let's just do as much work as we can in say half an hour to an hour. So let's take a look at the second problem on the projecteuler.net archive. So this one we're going to be looking at a Fibonacci sequence, and if you're not familiar with what a Fibonacci sequence is, well, I normally don't see them starting with 1 and 2. Normally I think of them starting with 1 and 1, but that's neither here nor there. So in a Fibonacci sequence, it starts with 1 and 2. To get the next element in the series, you add the last two terms. So the sum of 1 and 2 will give you the next term, which is 3. Sum of 2 and 3 will give you the next term, which is 5. The sum of 3 and 5 will give you the next term, which is 8, and so on and so on. So you see at each moment in the series, you're adding the last two terms to get the next term in the series. So what we want to do in this problem is we want to add up all the even terms. So find the sum of all the even value terms that don't exceed 4 million in our Fibonacci sequence. So this one I suspect will also be pretty simple. So let's go ahead and get started. I'm going to open up a new Python file, and we're going to call this problem 2. Alright. So let's see. Let us start our Fibonacci sequence. Let's see. So let's build an array. Let's see, fib equals, I'm going to start this with 1 and 2. Okay. So, and we're going to say, and we have a sum that we're trying to keep track of. Sum equals 0. Let's call this result. Result equals 0, and this is what we're going to print to screen. So we're going to keep adding up all the even terms. Actually, since 2 is an even term, let's just say the sum so far we have is 2 for all the even terms are in this. Let me zoom in so it's not as small, and let me make sure it's not covering. I have this banner covering up a little bit of my code. Let me minimize this. Hopefully you guys can still read it. Okay, sorry about that. So I'm building an array with that starts with values 1 and 2. And the idea is, while I don't have any element in this array that's bigger than 4 million, I'm going to keep adding to this array, and yeah, I'm just going to keep summing up the even terms. So let's see, is max a function? Max fib is less than 4 million. 4, 1, 2, 3. This is not the most efficient way of going about this. I should only look at the last term. So how would I look at the last term? Would it be fib minus 1? Let me just double check this for a second. Print fib minus 1. I think this looks at the last term. Ooh, that's not what I want at all. Oh, because we're looking at the last problem. Let's see. Let us run this new script, problem 2. Yeah, I think that'll do it. So while fib, while the last element in our array is less than 4 million, we are going to append the last two terms. Let's see, let's all call current term equal to fib minus 1 plus fib minus 2, so that'll be the second to last term. We're going to append this to our array, fib current term, and we're going to check if it is an even number. If it's an even number, then we're going to add it to our results. So if current term mod 0, why am I getting this thing here? Colon expected. Where's a colon expected? Whatever. If current term mod 0, current term mod 2 equals 0, then we're going to add to our result. Result plus equals current term. And lastly, let's print out our results. Okay, now, so I'm getting about 4,613,732 as our result. So let's go ahead and plug this into our problem here. I'm not signed in. Let me go ahead and sign in so I can input my answer. Let me take a sip of coffee. All right. Let's see if this works. 304.23. What do you know? It's right. So we could go back and take a look at our problem. You know, I said in the last video, you know, I wouldn't really worry too much about optimization. They say on the website that, you know, the code shouldn't take more than a minute to run. I'd say that's probably even generous. I think, and, you know, for a question like this, which is so simple, you know, it's you know, kind of hard to get it to run for more than a second. But, you know, I'd say if we wanted to optimize this, you know, for memory, we wouldn't keep this array, you know. We would probably only store the last two terms that we looked at and just kind of keep updating that as we go. So, you know, that's one way to optimize this. I don't know if append is the most optimal way of adding to an array, but, you know, that wouldn't even matter if we only stored the last two terms. So that's, you know, one way we could improve this program, but, you know, I'm not really too concerned about this, especially for these earlier problems. So let's go ahead and move on. Let's look at problem number 3. Yeah, and let me update my little banner here on this tool. Cancel, so you guys know what problem I'm working on. Okay, and make sure this doesn't block any of my code. Let's center this. All right, so now we are looking at problem 3. What is the largest prime factor of this number? Let's go ahead and open up a new Python file, problem 3. So num equals this guy here. Zooming in again. So basically, what is the largest prime number? We want to ask ourselves, what is the largest prime number that evenly divides num? Well, let's see. How can we go about this? I would say we could run a script while, let's see. So we want to test all the numbers for I, or let's just say for I in range num. What we want to do is we want to check, actually we wouldn't even need to go all the way up to num, we would go all the way up to num over 2. Maybe the ceiling, is ceil a function? Ceil, I think we need to import math. Import math. Ceil. Okay, and I think this should work. Let's see, I'm just going to make this a float, and I think ceil turn output to an integer, and this should work. So we want to go all the way up to there, and we want to record the largest prime. So what we'll do is for all these values I up to num over 2, we want to check if if is prime I, and this is a function I haven't created yet, but I'm just kind of planning out what I'm going to do ahead of time before I get into the meat of defining this is prime function. And num mod I equals 0. Then we will say, okay, let's see, max prime factor equals I. No, I don't like I. I'm just going to switch this to N. It's, okay, so that should do it. Oh, and let's just set our initial prime factor to 2, or not 2, but 1. Max prime factor, because this number itself could be, prime. And yeah, let's see. So what is the largest prime number that evenly divides num? So we'll set that to 1. So now, before we can run the script, we need to define the isPrime function. Okay, so def isPrime, and we'll accept an input n. So how do we check if n is prime? So I'm sure there's a lot of optimal ways of doing this. I could, kind of look this up on, Stack Exchange to find, a quick script to run this. So I might do that for future problems, but I'm just going to do this kind of the naive way. So I'm going to call this naive isPrime. So the naive method is just to, well, the super naive way is to check all the numbers up to n and see if anything else besides 1 and itself divides it. So I think we can do a little bit better than that. I think you only need to go up to square root of n. I'm not going to, talk too much about why, but, let's only go up to math.ceil. Okay, let's call equal math dot ceiling of math dot square root of n. Okay, so for I in range, so we're not going to start at 1. We're going to start at 2. and go all the way up to n, but not including n. For I in range 2 through n, so we're going to check if this number, if our value I divides n. If I mod n equals 0, I'm going to get rid of these parentheses. So if we get a number that divides n, we're going to return false. We'll say that it's not prime because we found something. Now if it manages to go through, you know, all these values up to square root of n, oh, and I didn't even use val, up to the square root of n, we can successfully say that our value n is prime, so we'll return true. True, false. Alright, so now I think we can run our script and see what happens, and see what our max prime factor is. Let's see, run problem 3. We get an error here. Integer argument got float. So what's wrong here? Should I cast this as an integer? Range result has too many items. Okay, so I think our array is too large, so we might have to convert this to a while loop. You know, before I convert this to a while loop, I just want to make sure my isPrime function is working, so I'm just going to run a simple test. So let us, let's see, print naive is prime 3, 17, numbers I know are prime, 20, 102. It's still kind of mad. Let's see, where are you mad? Range 2 to val. I'll have to convert this to a while loop as well. Okay, let us go ahead and do that. So let's start at I equals 2. While I is less than val. Well, let's just simplify this a little bit. I plus equals 1. Let's see if this works. True, 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 true. It says everything's prime. What's wrong? Make sure this is working correctly. Maybe I should cast this as an integer. I don't think mod plays nice with floats. Let's try this again. True, 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 true. Same result. it's not printing anything. Let's see. Does it matter? Well, I is less than square root of print. So it looks like it's working. So these first two are definitely prime, but this guy's definitely false. So it should be going up to 5. So as soon as maybe it should be less than or equal to. Let's give that a try. Is this backwards? I think it should be n mod I. There you go. Alright, so that looks like it's working. N mod I. Okay, good to know. So now now that we have our is prime function working, now let's see if we can solve the original question. Let's find the largest prime factor of this guy up here. So let's see, we will start our while loop at 1. While n equals 1. While n is less than int, let's do less than or equal to int Where are you, man? Oh, too many parentheses. And num mod n equals 0. Blah, blah, blah. Let's give this a run. Make sure this is even running in the first place. Print. Starting. So should we be going up to num over 2? Should we be going up to square root? Math dot square root of num. That should help it run a little bit faster. I don't know how much faster. On top of that, we could kind of reduce this by a factor of 2 by eliminating all even numbers. Then all multiples of 3. How could we do that? What is a smart way of doing that? Yeah, even the square root of this, you have this is going to run at a factor of n squared because you have two nested loops. This guy shouldn't be running this slow. So this is definitely where optimization comes into play. So can we improve our is prime function? Well, I could do that, I could cut it down by a factor of half by skipping every even number after 2. But then why don't I skip every, number divisible by 3 after 3? Still going. Okay, I'm going to go to stack exchange. Look for an easier way to check if a number's prime. Let's see. To check if a number's prime. Yeah, I guess, this naive is prime looks like one of the top answers, surprisingly. I mean, there's some tricks to make it a little faster, but surprisingly. I'm surprised how, optimal this naive is prime is actually a pretty good method. Alright, but there has to be a way to optimize this loop over here than just checking every value and checking if it evenly divides. I have an idea. We could keep reducing this value over here so our boundary gets smaller and smaller. Is that going to work? Let's try something. L equals int math.ceiling square root blah blah blah. Start at n equals 2. And we're going to say, okay, if am I not incrementing? Has that been my issue? I haven't been incrementing n. Oh man. Alright, let's try incrementing n before I go crazy here. N equals 1. Plus equals Okay, I've been driving myself crazy because I haven't been incrementing. I've been treating it like a for loop. Oh, and I gotta just make sure it's starting. But, you know, I think this will, well, this is 100% guaranteed to stop at some point, but who knows if this is going to get it to me fast enough. But let us, you know, try this approach I was thinking about. So if it is prime and num mod n equals 0, let's divide our value by n. Man, it actually finished. 6857. Okay, let's give this a try. And then, you know, I'm gonna try to optimize this because, you know, I got the idea and now it's kind of stuck in my head. So let's give this a try. 58590. Let's get this, check this out. Ah, we got it. But, you know, I'm kind of determined. I still want to optimize this guy. So val equals val over n. Let's see if this gives us the same result, but hopefully faster. Oh, it didn't give us the same result at all. Why is that? Why can't I divide it by that prime factor? Oh, I have an idea. Max of n and num over n equals val over n. Okay, let's give this a try. I'm very curious if this works. Ooh. Okay. Oh, we didn't check if this is prime. Man, if is prime num over n else x prime factor equals n. Alright, I'll save this for another day. This is good enough for me. $68.57. All right. Let's move on to problem 4. Okay, let me go ahead and copy and paste this up into the banner. Okay. So a palindromic number reads the same both ways. The largest palindrome made from the product of two-digit numbers is 91 times 99. Find the largest palindrome made from the product of two three-digit numbers. So what I'm thinking is we're going to have two nested for loops going up to 999. Check if the result is palindromic, and that'll be it. Let's give it a try. New Python file, problem 4. So we need a way to check if a number is palindromic first of all. Well, let's see. Def is palindrome n. So how can we do this? Let's see. So maybe what we could do is we could convert a number into a string, checking and just kind of going down the middle. Can I convert it to a string? Oh, that's what Stack Exchange is for. Convert number to string array Python. Another way we could do this is, kind of mod it by we could mod it by 10 to get the first digits. And then divide it by, I don't know. Can we convert this to a string array? I think this would be easier than, kind of worrying about modding and convert. Okay, so let's convert number to a string in Python. Let's see if we can convert a string to an array. No? Okay, so it's just a matter of casting. And convert string to array of char in Python. What if they're not separated by a comma? List. Oh, that seems pretty easy. Okay. Let me zoom in here. Okay, so n equals list. Okay, r. Let's call it r array equals list str of n. Let me print this out to make sure it's doing what I hope it's doing. Okay, let us say print is palindrome 1053, 1000. Oh, and running the wrong program. Problem 4. Do it. Yep, that's doing exactly what I want it to do. So what we're going to do is, let's see. Let's come up with two indices. Index 1 equals 0. Let's call it index 2 equals the length of array minus 1. And while index 1 is less than index 2, I'm going to kind of run through this list of arrays, compare, you know, the string at these two indices, and then increment and decrement accordingly. So let me end with that. Index 2 equals index 1 plus 1, index 2 minus 1. Okay, so if, so I want to say, okay, if they're not equal, then we're going to return false. Now if we manage to get through this entire array and nothing happens, we never get a situation where they're not equal, then we can say it's palindromic. Return true. But we have to get through this entire while loop. So let's go ahead and test this. 11, 0, 0, 0, 1, 1. And let's try a couple more. Oh. Print 1, 2. Let's see, 3, 4, 2, 4. Let's try this out. True, false, true, true. 1. I'll do a little bit more testing. And 8. True, false, false, false. Cool, looks like it works. So the original problem is we want to find the largest palindromic number using two 3-digit numbers. So let's see, what's a good way of doing this? Well, we could start with 100. Num and 1 equals 100. Let's see. Let's see. 1 equals 100. Okay. For I in range 100. No. Range starting at 100, going up to 999, but not including 1,000. And the naive way would just be to kind of repeat the statement with a J, or an N2. I think we can be a little bit smarter about that, instead of testing all of these. Can we? Because there is going to be some repetition, so like say, if we don't want to do N1 equals 100 and N2 equals 900 twice. Like say we don't want to do 100 times 900 and then 900 times 100. So what's a good way to avoid that? What is a good way to avoid doing that? Do I only go up to, but we also want to do, let's see how fast this runs. Go. And max palindrome equals 0 and 1 times if is palindrome and 1 times N2, then max palindrome equals N1 times N2. Print max palindrome. 580,085. I mean, it ran pretty quick. Should I start at N1? I think this is how you can make it go a little bit faster. It clearly didn't work. 580,085. Yeah, it's kind of weird. I don't know why I get a larger number if I'm reducing the space of values. Minus N1 plus 100. This is kind of a same way of doing it. Ew. Yeah, I'm just gonna stick with the naive implementation. Let's see what happens here. And put it in 25709. Check it out. I got it wrong. Find the largest made from the product of two 3-digit numbers. So I'm pretty confident this guy works. Let's see, print N1 and N2. Let's see what happens if I do this. $924 times 962. Let's see, 924 times 962. I mean, that's correct, but you know, why didn't it do that? That's weird. Like, why didn't it try to multiply these two values if I started at, say, 100? Because, I mean, you should still get the product of those two, but I don't know. Not something I feel like debugging. Let's go ahead and put in 888,888. Because clearly it works. 24065. Alright, that's not even right. There's a bigger one. Made from the product of two. Find the largest palindrome made from the product of two 3-digit numbers. 924 times 962. Yeah, it works, but that's not big enough. You know, a smart way to do this would just, you know, to start from 1,000 or 999 and just work backwards and just print out the first thing you see. N1, N2 equals 999. Can I reverse this list? No, that's too fancy for me. into 924, 962 looks good. It's a pretty big number. Not big enough, I guess. Why don't you like that? Let's start from 900, 900. This is just confounding. Why doesn't it like us if we start at just 100 and 100? So it's clearly, you know, I'm getting larger numbers, but you know, it just doesn't make sense to me that it's kind of skipping over 993 and 913. There's clearly something I'm overlooking. I'm not sure what it is. Eight, 6, 3, 3, 3. Oh, I got it. Oh, you know what? I know what I did. And it's just looking at the latest palindrome, or the latest palindrome I found. It's not checking if it's larger than the last product I found. If n1 times n2 is larger than max palindrome, and okay, so let's, I'm going to try this again. And from N1. Okay, that works. It works pretty fast too. Cool. So yeah, it was just something stupid. I wasn't comparing the newest product to check if it was larger than what I've recorded thus far. So yeah, so this has been almost an hour. I think this is a good place to stop. I might get on later to kind of work on my slot simulator, but yeah, thanks for watching.